Today we'll explore how to implement pagination in GraphQL, which is an essential feature for any API working with large datasets. I'll walk through two major approaches, offset-based and cursor-based pagination, compare their trade-offs, and show how GraphQL handles them efficiently with type schemas. And we can then conclude with best practices, backend design considerations, and a real world example using a blog post feed. So why do we need pagination? Imagine you have a list of 10,000 blog posts and a mobile app that fetches all of them at once. This leads to slow load times, UI freezes, server strain, and bandwidth waste. Pagination solves this by breaking the data into manageable chunks. For example, loading 10 posts at a time instead of 10,000. Besides performance, pagination also improves UX. For example, supporting infinite scroll, load more buttons, and server-side tables with filters. Also important for protecting server resources, especially when exposing public APIs. In practice, we usually implement one of the two strategies, offset based, where we say skip the first 50 items and return the next 10, and cursor based, where we say return the next 10 items after this unique marker like an ID or timestamp. GraphQL supports both, but each has very different implications in terms of performance, data consistency, and user experience. Offset based pagination is simple and familiar, especially if you're coming from SQL or REST APIs. For example, here we fetch 5 posts starting from offset 10. This means skip the first 10 posts, then return 5. This maps well to SQL's limit and offset syntax and is very easy to implement in resolvers. However, there are some problems. Performance degrades at high offsets. The database still has to scan and skip to those records. And data shifting, if a new post is inserted at the top while a user is paginating, items may be duplicated or skipped. These issues make offset-based pagination unreliable for real-time or user-sensitive applications like social feeds. Cursor-based pagination avoids these issues by using a unique identifier for where the last page ended. Instead of offset, we can use an after argument with a cursor, which could be a post ID, timestamp, or a base64 encoded string. We also get a page info object that tells us if there's more data and gives us the end cursor to use in the next query. This model supports consistent and efficient pagination even if new posts are added or deleted during user navigation. This is the preferred approach in GraphQL and used by Relay, GitHub, and other large GraphQL based platforms. Here's a direct comparison to clarify when to use which. Simplicity. Offset is easier to set up. Consistency. Cursor ensures stable results when data is updated mid-query. Performance. Cursor scales better with large datasets. Offset suffers at deep pagination levels. Use cases. Offset is okay for small, more static data. Example admin tables. Cursor is ideal for dynamic real time feeds or APIs used by many clients. If you're building a high quality front end experience or public facing GraphQL API, cursor pagination is usually the better long term investment. GraphQL schema for cursor pagination. Let's look at how this is defined in a typical GraphQL schema. We use a connection pattern with three key parts: edges, a list of items, each with a node, actual data, and a cursor. Node. The node is the actual data, the actual object being paginated, like a post. Page info. It's a metadata about the page, such as whether there's a next page and what the end cursor is. This structure is inspired by Relay, but you can use it without adopting the full Relay spec. It also decouples the schema from internal DB structure. You don't expose internal IDs directly. Here are some backend tips for implementing cursor based pagination. Use a stable indexed field for the cursor, like created at or a globally unique ID. Encode cursors using base 64 so they are opaque to the client. This avoids leaking sensitive structure. In resolvers, filter data using a where created at cursor or ID cursor class depending on sorting. Avoid decoding too much info into the cursor. It should be a minimal bookmark, not a full query snapshot. Always return has next page and end cursor to guide the client. Imagine we are building a blog platform with thousands of posts and a mobile front end that uses infinite scroll. Using cursor based pagination, we fetch 10 posts at a time. As the user scrolls, we use end cursor from the previous query as the after in the next query. This avoids duplicates even if new posts are created while the user is scrolling. because we paginate relative to a specific item, not an offset. This approach provides a smooth, fast, and consistent user experience, perfect for real world apps. To summarize, use offset based pagination for small static data sets or internal tools where consistency isn't crucial. Use cursor based pagination for production APIs, mobile clients, real time apps, and when data may change between page loads. The best practices are always sort data before paginating, that is, by creation, date, or ID. Use opaque cursors to avoid exposing internal logic. Think carefully about default limit sizes. Avoid returning too much data at once. Consider adding pagination to nested fields as well. For example, post comments first 5.